In March 2022, there was a very sad incident. The Russian Defense Ministry spokesperson, Igor Konashenkov, claimed that Russia had used the Kinzhal hypersonic weapons for destroying underground targets. That was a sad incident. But underlying that incident was something called as technological stuff, which is the Kinzhal itself. The Kinzhal has almost all that is needed at the moment what a hypersonic weapon should be, flying at Mach 10, claimed speed of Mach 10, a range of 2,000 kilometers, maneuverable and yet controllable. It is still regarded as a cozy, ideal weapon for tactical and strategic fronts. While the experts do argue that Russian claims are somewhat misleading in the strict sense of the hypersonic definition, nevertheless, between the claims and the various counterclaims about definition of Kinzhal, the one fact unarguable is the degree of unpredictability that a hypersonic weapon poses whenever it is fielded. Now, earlier the same year, we've had another very pleasant incident. Again, there are arguments about this, where a GEO satellite had been used for carrying out space debris remediation operations in the deep space. To some experts, this had sounded as a prelude to testing a counter-space strategy by one of the major space powers. But the ultimate result was much more pleasant. We were able to remove a debris from the orbit, and it was much pleasant, of course, what Kinzhal had done. And this is exactly what the effects are of what I call as dual-use technologies. They may be destructive and beneficial both at the same time. My school had a motto, Scienta cum Virtue, St. Anthony's. I never understood why they wrote this thing. It took me about 30 years to realize there's no use of science it does not carry virtue. It's about saving people more than killing them. So my talk would be about how to save environment, how we can use this military technology to do something good for the people, and how our country and the region can collaborate in this range. Okay, in simple words, we can define dual-use technology as something that has both commercial and military benefits and includes everything under the technological domains. But in this session, I'll be considering only two of the technological domains, the hypersonic and the spacecraft operations. And in that, I'll be talking about counter space for the benefit of space itself. The concept of dual-use space technologies dates back to about the times of Cold War. And over the period of 7 decades, a wide range of space technologies have seen a process of evolution from military applications into the civilian domain. And I've listed here some of those aerospace technology applications that have gone through that transformation. What is very sad, I would say, is that the reverse has not been true. It's very rarely that we have seen that a civilian technology application was built and then that was converted into a military use. And this is something very sad, and that's actually killing the purpose of the whole thing that we are trying to build up. Although I believe that the commercial satellites have done a lot of wonderful job in offsetting this paradigm significantly, nevertheless, there is still room in evolving strategies that could encompass something like use counter space operations for the global benefit of mankind. And I'll try to do that because my team here of astrodynamics has done a wonderful job, and Air University, of course, has supported me a lot in this regard. I will start first with the hypersonic technologies. Now, technologically, from the time of conception, a hypersonic system is envisaged as something called as an invincible weapon, a claim that is likely to hold good for now, for a couple of years, till the counter weapons come up, get tested, qualified, and are fielded into the battlefield. So the question is, what makes hypersonic weapons so invincible, and why there is always an underlying desire by the major powers to have a grip on the system? In very simple definition, hypersonic systems are prompt, they're accurate, and they're supposed to remain undefeated in the battlefields. They accelerate at speeds greater than, of course, Mach 5, which is the hypersonic domain. They follow something called as a depressed trajectory, a very low flight path angle for those on this side who understand that part. And that makes them undetectable, even at high altitudes from the high altitude radars. Now, when they are at about 40 to something kilometers, they can perform maneuvers at that speed, and by the time they are into the terminal phase, it makes it very, very difficult for your counter weapons to come up and intercept, and that makes them highly unpredictable because they're flying missiles. As of now, the hypersonic technology is based on two different configurations. Primarily, the BGVs or the boost glide weapons that use the rockets with combined cycle engines with the hypersonic gliders, and the hypersonic cruise vehicles, HCVs, that use hypersonic air breathing systems. And as can be seen here on this, this is the trajectories. Now what we see here are the white lines, and these white lines vividly show that all three forms, the ICBMs, the HCVs, the BGVs, are all hypersonic systems. They all follow different trajectories. None of them have a commonality. And that is what is interesting when we're talking about these systems. To do that, I built up a small CONOPS. And this CONOPS uses all three systems in one package. So if you compare the trajectories of all three systems, the lofted parabolic trajectory is that of a ballistic system such as an ICBM. Now if you look at this trajectory, it is getting detected by the radar very early on, even before it has reached its apoapsis. And because of this detectability, it can be traceable and is fairly predictable by an advanced radar system. The BGV and the HCV trajectories, however, are depressed. They are in the upper reaches of the atmosphere and not visible to the high altitude radars, not until the last 40 kilometers or something are left, beyond which hypersonic maneuvering will make it impossible for any contracting weapon system to neutralize this thrust, thus attenuating the lethality of this hypersonic system manifold. Technologically, hypersonic speeds will offer another very big advantage to the operators. They are going to fasten the OODA loop, and the observe, orientate, detect and act loop is going to be so fast that the adversary will not have time to react. And this would be the key to winning the battlefield competitions. Now, the advent of hypersonic, as I may say, is not something coincidental. It has always been integral to the great powers competitions strategically, even as early as the 1940s. And the United States had possibly had the longest history, starting from the theoretical designs to X-43 to X-51, and all that. They led this whole development for many, many years. Albeit, there were two other major powers in the race. Of course, that was China and Russia. And while they were neither oblivious nor they were benign to the idea of the hypersonic system, but they were not visible at that time. So while the world was, as I say, glued onto the marvels of DARPA and other big research agencies doing their stuff, somewhere in the Far East and the North, a lot was happening. And then there was a gap between 2011 and 2018 in the American technological history. If you look at technology, there's a strange gap. It's a funding gap. And that was the gap which Russia and China filled in just in time, the JIT concept. And that is what happens then. Today we have 5 declared hypersonic systems, 3 fielded weapons from Russia, 1 from China, and then we have the WU-14. So as I say, that while the ARRW was still being investigated or refined, Russia was the first one to field in the qualified hypersonic weapon, the Avangard, in the military. Now, a couple of years later, that was in 2021, China just raised the bar too many notches up, because the hypersonic test flight vehicle changed from the usual suborbital category and started becoming an orbital vehicle encircling the Earth 3 times. This is the first time a weapon has encircled the Earth. And this made China practically the global leader in this race. The global frenzy is now growing. Hypersonic systems development, research has taken a huge jump. It's visible on this list, and we can see that there are a number of weapons under development in different parts of the world. This implies, and I believe, that the coming decade will possibly witness an array of novel, highly unpredictable systems making their way into global conflicts. And that's going to be very, very dangerous for everyone. My question here is that the hypersonic weapons we've seen their lethality, but can they be used for something good also? And the answer I say is yes. It's because the hypersonic technologies that we see here, the hypersonic technologies have the same power and they follow the same maths. The maths on the left side is what can be used to build something like that on the right side. And this is where we can derive civilian technologies. The best case in point is a hypersonic cruise vehicle. It can revolutionize air and space transportation by potentially lowering the cost. The current cost is at $2,500 per kilo in space, in low Earth orbit. And we need to bring it down to about $15 per kilo so that it can become accessible to everyone, like everyone in this room should be able to travel. And that is the solution that hypersonic offers. Air University is not oblivious of this potential either. At the Aeroflux Lab, we at the Aeroflux Lab have been working together with various private and the government sectors to evolve combined cycle power plants to energize the next generation, possibly energize the next generation of space travel and the hypersonic space transportation system. And this, I believe, is the true potential that we need to cash on. And this can offer global benefits. A technology of this kind can offer global benefits for the mankind before it becomes a weapon of destruction for humanity. Now, unfortunately, when we're talking about all the goods of this thing, it is very, very sad when we see that in our very immediate neighborhood, there is so much of potential in this technology, but our neighborhood, India, of course, has, with all her resources, elaborate resources, is investing so heavily on the military aspects of hypersonic and CSO alone. The continuing and unabated development of hypersonic BrahMos, the Prithvi system ASAT, and an ever-increasing array of military satellites. Remember, now there used to be just one constellation of Cartosat. Now there are actually 3 different constellations of military sats alone from India. And all this has happened the last 5 years when this was all a possibility. These are all a testimony that this impoverished region is fast getting pushed yet into another impending arms race. And that will drag, very unfortunately, Pakistan too along with it. Because we don't have an option, we have to maintain a minimum credible deterrence. It would have been immensely beneficial for this region, for these people, and the global community had the destructive technologies being first used in their dual role for the prosperity of the people.